Hello and welcome to this demo on Amazon SageMaker. Today I'm going to take you through the next generation of Amazon SageMaker to show you how it can now accommodate the entire data lifecycle from data ingestion through to analytics through to AI and ML. And this is combined through the Amazon SageMaker Unified Studio, giving you a single integrated environment to switch between these different types of compute, and also giving you things like data and AI governance and Lakehouse integrated into the experience as well. And as we go through the demo, we'll see a bit more of this in action. So without further ado, let's head over to the console and look at starting with a SageMaker Unified Studio domain. So to get started, I'm going to go to SageMaker in the AWS console, and I'm going to select to create a new Unified Studio domain. Now for exploration or initial POCs, I suggest using this quick setup, which will launch a compatible VPC for you. I have already done that, so the VPC is already launched for me, but essentially that just allows you to launch a CloudFormation template that will create the required resources. Now we can give our domain a name. So I've just given it the name demo, and I'm going to use the service roles that will be configured for me. I've selected the VPC that was created as part of that quick launch stack, and then I'm going to select the private subnets from that VPC to launch into. I've already granted generative AI model accesses through Bedrock, but if you need to do this, you can go through to the Bedrock console and you can provide access to the models that you see fit. I'm going to keep the ones I've got here, and again I'm going to use these default roles for me, and I'm going to hit continue. The next thing we can do is we can select to use IAM Identity Center for authentication into SageMaker Unified Studio. I'm going to select that and use a pre-existing user that I have within the Identity Center account instance. This means that once my portal and my SageMaker Unified domain is set up, I can log into that portal external to the AWS console. So you can see me navigating to that portal now. So this is one advantage of SageMaker Unified Studio, is that I can now use my existing single sign-on credentials, in this case Identity Center information, to sign into the portal. I don't need to have an AWS console login to access this. So once the user has logged in, you'll see that they're presented with this integrated environment where they can start to explore a variety of different capabilities, such as the data catalog, exploring available models, through to different build environments providing different types of compute, and they can start applying governance at scale with integration with the SageMaker catalog. We're going to explore some of these components in more detail, but one of the things you first want to consider is creating a project. So let's get started with creating a project. And a project is essentially a logical container for bundling together membership, your users, access to data, and access to compute. And you can see that there's different project profiles that give you different flavors of compute specialized to perform different tasks. So we can pick one that gives you a good range across all capabilities. And you can see here it's giving us things like AI ML capabilities. It's giving us large scale data processing through EMR, generative AI capabilities through Bedrock. We might pick something that is more focused if we were more data science oriented team and specifically looking at Gen AI. Or again, likewise, if we're more analytics focused and just looking to do some SQL analytics, we could pick the SQL analytics profile. For now, we'll go with the all capabilities. It's important to note here as well, there is some ability to customize the different types of profiles and environments you make available as well. But for now, we're just dealing with the inbuilt ones. And so as part of the profile we've just selected, one of the things that will get created for us is a Lakehouse database. And you can see here, I've just overridden the name of that to be AnalyticsDB, but I'm going to keep everything else the same, click continue, and then create the project. And so essentially what's happening now is SageMaker is provisioning those resources for me behind the scenes. So that template of the profile of the environment is being used to create a variety of different compute for me, which is going to then allow me to interact and analyze my data. So once the project has finished creating, I'm brought through to this project homepage. This gives me some details about my project, and it also means I can start exploring the data and compute that I have available to me. If you need to browse to see which projects you have available to you, you can do so using the Browse or Project screen. This will show you all the projects that are visible to you, and so you can switch between your different projects with ease. So one of the first things you might do on setting up a project is look to start your analysis. And so we might start by looking in our data catalog. So I'm just going to go and browse some of the assets available to me. You can see so far, we only have those GenAI models that we enabled through Bedrock. And that's because we've just set up this domain, so it's completely empty otherwise. But that's an important thing to note here is that this catalog captures the metadata for things like AI models as well. It's not just data governance, it's data and AI governance. So for now then, I'm going to start by uploading some data. You can imagine that at the start of a piece of analysis, I might have some data, a snapshot of some data, an export of some data, and I want to start exploring it to see what might be useful. So I've come through into my build and query editor, and this is giving me this integrated experience across a range of different compute. So out of the box, because of the SageMaker profile that we used, we got a lakehouse deployed for us as part of the project creation. And you can see here, this is the analytics DB, so that name that I overrode has been created for me. And there's a unique identifier appended to it, just so that we don't have any naming conflicts. So this is a lakehouse, a glue database environment, and currently there's no data. So one of the things we might do to start with is to upload some data. So I'm going to select to create a table. I'm going to drag a file that I've got just locally. So you can imagine that this is an export of some data that I might want to experiment with. It's correctly identified that this is CSV format. It's going to call the table the same name as the file name, and it's going to store it in my Analytics DB database. On clicking next, you can see the schema that was detected for me. That's all looking correct, so I'm going to go ahead and create the table. What happens now for me is that SageMaker behind the scenes has uploaded that data into an S3 bucket for me and created the Glue database table within my Lakehouse environment. So you see now I have this table available for me, and I'm going to go and query that with Amazon Athena. And can we see now that I've been able to use Athena to start exploring that data. So a very quick way of getting started with your data exploration. One thing you'll have also noticed is that actually I can switch between these different flavors of compute. So we had, as part of our project profile, both an Athena workgroup and a Redshift serverless environment created for us. So you can see now that I'm issuing the query with Redshift, and again the data has been returned, and we can start exploring with Redshift queries. So this is one of the big benefits of SageMaker Unified Studio. I now have the ability to switch between these different types of compute, but from the same integrated environment, the same experience. I've not had to leave this console at all. So one of the things we can do now that we've uploaded some data is if we head over to the Glue console, so this is back in the AWS console under AWS Glue, we can go to our data catalog, select databases, and we can now see that the Analytics DB that was just created for us is visible. So this is what Amazon SageMaker has done for us. It's created that database behind the scenes. And we have now have our table available in this database through the upload experience that we've just done. So all of this was automated for me. It's allowed me to have that self-serve experience from SageMaker Unified Studio, but it's still using the Glue database behind the scenes. Similarly, for the Redshift environment that was deployed for us as part of the project profile, we can again switch over to the Redshift tab. So back in the AWS console, into the Redshift service, we can see that this Redshift serverless namespace and corresponding workgroup have been created for us. So that's this environment that we're seeing here in the SageMaker Unified Studio portal. So again, this has been created for me automatically based on the profile that we selected. And if we can start to explore this Redshift data warehouse, as you can imagine at the minute, it's currently empty, but it's giving us that compute capability. So at this point, what we might want to do is integrate an existing data warehouse as part of this environment. So it's very likely that you have existing data warehouses available, and we want to be able to access that data. So one thing we can do is head back to the project homepage and switch to the compute tab. From there, you can see the different flavors of compute that you have available to you. We already have our project Redshift serverless environment that was deployed based on the project profile we selected. And we have a few other types of compute available depending on the specific profiles that you use. What we want to do though is add additional compute. So I select to add compute, and I'm going to connect to an existing resource rather than creating a new one. And we see that we have the two options available, whether we want to connect to a Redshift provisioned or serverless warehouse. So I'm going to select serverless, and I'm going to select the existing work group that I have available to me. So if I switch back to the Redshift serverless page, you'll see that I have the project environment that was deployed for me. But then I also had this existing analytics warehouse as well. That's the one I'm connecting to here. For the purposes of this demo, I'm just going to use this admin credential, and then I'm going to add. Once that compute has been added, we can go back to our compute tab, and we can see that we now have the analytics data warehouse available in our compute. So again, now if I head back to my query editor, you'll see that this existing warehouse now appears in my Redshift dropdown. So now if I click to explore, you can see that we connect to the warehouse, and then I can explore the data that I had already existing in my warehouse. So you can see here I have some sample tables just to show that this was pre-existing data, and I'm able to query it just like before. So you'll see here that of course at the minute the only option is to query with Redshift because this is Redshift data, but I can still query it from this same experience. I'm not having to switch between IDEs and different consoles. I'm using the same access patterns, the same experience in the editors, and I can now query my existing data warehouse alongside my project-based sources. You see here that the lakehouse remains unchanged. We've not changed anything at this point just yet. So one of the things I might want to do next is to register my Redshift data into the lakehouse. The reason being is that helps unify your different data sources together into a common catalog, and the lakehouse enables you to put an Apache Iceberg compatible API around your data sources. So now not only can I have my lakehouse catalog containing assets from a variety of different data sources, but I can now use Iceberg compatible query engines across those different assets. So to do this, we'll head back to the Redshift serverless console and head into my existing analytics namespace data warehouse. And I'm going to select the actions drop down and select to register this with the Glue data catalog. So once we have registered, you'll see that we're taken through to the AWS Lake Formation console, and we can see that we have this pending catalog invitation. Now I'm logged in with credentials to administer, so I'm going to go ahead and accept. So I'm going to give the catalog a name. I can enter a description if I desire, and this is where we can choose to make this accessible with Apache Iceberg compatible engines. So I'm going to make sure that this is ticked. This is what gives us that flexibility to use different types of compute as long as your compute can use the Apache Iceberg API. To do this, we need a data transfer role. This is a role that I've pre-created based on the AWS documentation. And then I'm going to go ahead and select next, next, and then create the catalog. And we can grant permissions just as normal with lake formation. So this is another advantage of unifying those catalogs, those data sources in the SageMaker Lakehouse, is we can use lake formation to control access to it. So one thing I'm going to do now is go back to my analytics project and get the project role ARN. So this project role ARN determines the role that the project uses to get access to data. So back in lake formation, I can select to grant permissions to this particular role. So here I enter the role for my project. I choose the analytics namespace catalog. And I'm going to give this all privileges and hit grant. So it's just like applying normal lake formation permissions. So now I can go back to my analytics project, switch back to my query editor, and we can see now that the analytics namespace, so the data from our Redshift data warehouse, has now been registered in the Lakehouse. I can also now select this dev catalog, and I can grant permissions to my project role to be able to access this data. So at the minute I only have the public database, and I'm going to select all tables. I'm going to give all permissions and hit grant. The other thing you'll notice is if we go back into our analytics namespace, this is where we can now confirm that our data has been registered with the AWS Glue Data Catalog, and that we have this open source engine compatibility enabled. Now that I've granted the relevant permissions with lake formation to my project role, I can come back into the SageMaker Studio environment. I'll just refresh, and I can see that my analytics namespace is now registered within the Lakehouse. So my Redshift data warehouse has now had its namespace registered into the Lakehouse, and I can now explore this data, expand this down, and we can see that those same tables that were available to us directly through Redshift are now available in the Lakehouse. And now I can start querying them. And not only can I query them with Redshift, but I can now also query with Athena too. So I've just used Amazon Athena to query this data, but I could then likewise switch and choose to query with Redshift instead. And it's the Lakehouse that gives me this flexibility and observability, because I now have my different catalogs from a variety of different sources, so that both the Glue database and now the Redshift namespace available in a single environment. So far we've shown doing some analytics over some ad hoc data that we uploaded into our Glue database. We showed using our Redshift provisioned environment as part of the project. We showed connecting an existing Redshift data warehouse. And we also then federated that catalog into the Lakehouse. So we've now got plenty of data available to us. But one of the next things we might want to do is explore building a transformation job. So one of the things I'm going to do to show the visual ETL job is just upload some sample data. So I've just created this files prefix under the S3 location in my project. And I'm just going to upload some sample data that I have locally. Now I'm going to upload that data to this S3 location. Of course, in reality, this data would probably be coming from a database connection or something like that, but I'm just for demo purposes just going to upload that as a flat file. The first thing you'll notice is that Amazon Q is integrated, so I can write a textual description of my job and have it generate one for me. And rather than asking for the job generating for us, I'm going to just build this myself because I'm just going to keep it simple. I've selected my Amazon S3 node and I've put in the S3 URI of the sample data we just uploaded. And you can see one thing that happens is this data preview gets generated for me. And this is showing me what my data looks like throughout the workflow. So to build this, it's as simple as adding nodes and adding on additional transformations. For example, I might want to split out the product ID so that I can have just the numeric component. So I can look for the available transforms. So I might look for a split string type transform. And then I can pick the column to split. So I will pick product ID. I've selected to split on the hyphen that was in the middle. And then I can give the new array that's produced a name. From there, that you'll see that the Glue data preview has updated to show the current status of our data throughout this workflow. So the next thing I might want to do is just to separate out the ID, the numeric ID part into its own column. So the next thing I'm going to do is select an array to columns transform. So I've picked my input column. I've specified some target output columns for the two pieces of information I'm interested in. And you can see that on entering that information, my product ID array is now split into the two pieces of information that I want. So the final thing I'll do here is add a transform to drop some columns that I don't need anymore. So I'm going to drop the original product ID, and then I'm going to drop the other product columns, leaving me with just the pure product ID in numeric form. Finally, what I might do is select to write to a data target. So rather than a transform, this time we're going to write to a data target. And from there, we can see that we can populate our Amazon SageMaker Lakehouse. We can pick the catalog, pick the database. So I'll pick my project database. And now we need to select a table. So we can see here that we need a target table to write to. So what I can do now is switch back to the query editor. And I'm going to create a target table in my SageMaker Lakehouse environment to hold this data. So I've created the DDL statement and I've run that to create the target table. So now if I switch back to my Lakehouse, I can see that this table is created for me, is ready to receive data. One thing I can do here as well is, because this is a DDL statement that's going to be useful to the project, I can save this to my project, and other members of the team who are also members of the same analytics project will be able to access that in the saved query tab. So they'll be able to reuse that code, and we can share and collaborate on that code as needed. For now though, I'll head back to the visual ETL flow, select my SageMaker Lakehouse endpoint. I'm going to refresh that list, and now I select my table as a target. I'm happy now that this is my completed flow. I'm going to save this to my project. I can again keep track of any changes that have been made, and this allows other people on my project to pick up this job, edit, modify, and run it as needed. When I'm ready to, I can run, and this will manage the process of spinning up the resources required to run this job behind the scenes, and once it's completed, it will all tear itself down and finish. Once the job has finished completing, we see the completed status. We can head back to our query editor to view the populated table. So let's just query that with Athena. And we can see that we now have our transform table, and we've extracted just the product ID, and we now have that as a numeric column. Again, by writing to the Lakehouse, we can also switch between the different compute types. So up to this point, we've created our initial sort of ad hoc data direct into the Lakehouse. We imported an existing Redshift data warehouse. We've then used the visual ETL tool to transform some data. So now maybe this represents something that we want to publish to the wider business. So what we can do now is look to use the data and AI cataloging functions within SageMaker to do exactly that. So to get started registering our data in the catalog so that other projects can start finding it and discovering it, what we're going to do is, I've come back to the project homepage. we'll select assets, and we'll see that so far within this project, we don't have any inventory assets available. So what we're going to do first to get started is create a data source. This is where we can start picking up some of the data that we have available. So I'm just going to call it the analytics data source. And what we're going to do here is pick up the data we had from our SageMaker Lakehouse environment. And we're going to connect to the Lakehouse environment that was deployed as part of the project. And the database is the analytics database that we created. And I'm going to apply this criteria, which is essentially going to pull all of the available tables. So if I go through to next, we can say whether we want to publish straight away. So I'm going to keep this selected as no. We'll just publish to the project's local inventory first. We will enable the automated metadata generation, and we will pick up on quality where it is available. I'll run this on demand, but we can set up schedules so that you can keep refreshing this data. But for now, we'll keep with on demand, and we'll hit create. Once the data source is created, we can then run it. And this will go and look at our SageMaker Lakehouse database and import the table metadata that it finds. So you can see that now it's found the sales pipeline data that we uploaded and the customer behavior data that we produced through the visual transform. So we can click into this now and see information around the schema. And you'll see that because we enabled that automated metadata generation, we can do things like ask for descriptions to be generated for us. At the minute, there isn't much data associated with this table, so users would find it hard to discover this asset and to interpret what it can help them with. But by generating this metadata, we can get a very detailed description of how the data might be used, what it could be useful for, etc. You can create your own custom readmes, add glossary terms, and add metadata forms. We can look at the schema, and you'll see again here that new column names have been suggested that are more business friendly, including column descriptions. If we had data quality information available to us, that would be surfaced here. And we can also view lineage information to see any transforms that have happened to this data asset along the way. So for now, I'm going to accept all of the suggested metadata, and I'm going to publish this asset. When I publish this, this is what makes this asset now searchable by other users. So we'll do the same thing for our next table, and we'll publish this asset too. And so now our data sets are available in the catalog. So imagine now that there's a consuming project that's trying to find information. Now in reality, this might be a different user and not likely to be the same person. But for simplicity, I'll stay logged in and just create a new project. I will keep the project profile the same, and we'll just quickly create this project. Once this project is created, then I might start browsing for different data sets that might be useful to me. So as a member of the marketing project, I come in and I might be looking for some e-commerce data. So I can start searching for terms that might relate to me, and I will have assets suggested to me. This is using things like the table name, the descriptions, maybe business glossary terms or metadata forms that you've attached to your data asset and that can help inform users' search. So as a member of this project, I might decide that this information, this data asset is useful to me, and so I want to subscribe to the asset. I can enter a reason and I can make the request. Behind the scenes, SageMaker now makes a request to the data owner, informing them that the marketing project and this particular user has requested access to the data. So now if I switch back to the owning project, which in this case is our analytics project, again, in real life, this is probably a different user that would do this grant, but I'm just going to switch over to the analytics project. I can see the request has come in, And I can decide to view this request and either approve full access, or I could apply some row and column level filters. So I might decide that there's certain columns that this user shouldn't see, or certain rows that this user shouldn't see. But for now, I'm going to select full access and hit approve. So what happens behind the scenes here is that SageMaker is granting the lake formation permissions for that project role, the marketing project role, to view this asset. Now that that has been approved, let me switch back to my marketing project. And if I go through to my query editor, you'll see that within my SageMaker Lakehouse, I now have the e-commerce customer behavior table ready for me to query. And again, I can issue an Athena query to start interacting with this data.